Okay, I want to graph this rational expression, this rational equation. So I am going to start by looking at other things. So first I'm looking, do I have symmetry? And I probably actually do have even symmetry. The reason I can tell I have even symmetry is because if I put a negative in there, it wouldn't change anything, it would stay. So it's probably going to have symmetry, which is useful. So this is even, okay? So that's useful because I know that one side is going to mirror the other side, and so that's helpful as I build my graph. Okay, then I'm going to look for my vertical asymptotes. So I set the denominator equal to 0, and I get x equals plus or minus 3. So I have two vertical asymptotes. And then my horizontal asymptote, I'm going to divide everything. So I'm going to get 4x squared divided by x squared divided by x squared, 9 minus x squared. So I'm going to get 4 over 1. So I have a horizontal asymptote at 4. Okay, so those are my asymptotes. So first two things, I have my asymptotes. I know I have an even symmetry. Then I want to look at this and I'm going to go, okay, well, let's find my x and y intercepts. So when does, first of all, the y-intercept is, the x-intercept's pretty easy, the y. So if I put an x equals 0, I get, what do I get? I get 0 over negative 9, so 0. And then for the x-intercept, y equals, well, this can only be 0 when the numerator is 0. So I can see this gives me 0, 0. So that didn't give me too much of useful, but hey, something. So I'm going to start building my graph here. So here's my base graph, my xy. Okay, and so I have 1, 2, 3, 1, 2, 3. So I have asymptotes there, and then I have a horizontal asymptote. Those are my vertical at 4. It's double checking. 1, 2, 3, 4. Okay, and I know I go through this point 0, 0. So now I have to figure out where all my points are. I don't have any other points. So what I need to do is I need to pick a point in each region of the graph. So I'm going to start out here, past here. I'm going to use, say, negative 5. Okay, I'm just looking for a point. So I'm going to plug negative 5 into here. Actually, calculator. I'm going to pick as many as you want. Usually it's pretty easy once you get going, though, to kind of figure out. So if I put in negative 5, I'm going to get 25 times 4, so I'm going to get 100 up in the top, divided by 25 minus 9. So, because I used negative 5, isn't it? So about 6. So coming down here, so just over 6. So if I come down here and I graph the one, that was 3, 4, 5, and then this is 4, 5, 6. I'm like right here. So now that graph, I know approximately what these graphs are going to look like, so there's that graph. Now I'm going to pick a point in here. I'm going to pick on either side of this. So say I'm going to do negative 2 now, okay? And then I'm going to do 2 because I also know that this is symmetric. So I know that 2 and negative 2 should be the same. So I come up here, I do negative 2 or 2. So I get, let's see here, 2 squared is 4, so that's 16. 16. Divided by 2 squared, so 4 minus 9. So this is negative 3.2. So come back here. So come down here. And this is true at both negative 2, so 1, 2, 3, 4, just past there, and there. I'm not drawing very well. Okay, so just past there. I know this is true for both sides. So now I've got this parabola in the middle. Now, obviously, you could pick more points if you're unsure about anything to do. Now, knowing that this is symmetric, I'm pretty sure that the last one is going to be out here mirroring this, but I'm going to pick a point anyways. I'm going to pick 6 just to be different. So I was at 3, 4, 5, 6. I want to see. Plus, that's going to give me an idea. 6, based on what I should see, 6 should be going this way. 6 should be getting smaller. So that's also going to help me kind of double check what I was doing, make sure everything looks good. So I'm going to put in 6. I'm going to come back up here. Okay, so 6 squared is 36. 36 times 4 divided by 36 minus 9. And I get 5.3. So that's exactly what I wanted to see because that's smaller than the other side. So this is 3, it's 4, 5, 6. I'm only just right down here. And this looks the same. Badly drawn, but still. But the idea being that 6 was a smaller number than -5, that matches what I should see. And if I would have got closer to this, say I would put in 3.2, I should be getting bigger. And you can go back and check that if you want. But so this gives you your graph. This gives you all your pieces. You can graph as many points as you want, but you do want at least one point between each of the asymptotes and between any points you do have. And since we knew this was evenly symmetric, that each side is the same, then I knew kind of that it should mirror each other, and that helped me build my graph. It also helped me check things as I went. So hopefully this helps you with the setup. This is mainly about finding those asymptotes, finding the intercepts, and then really just plugging in the rest. You're going to always have these same graphs that have this curved shape to them that really just go between the asymptotes. They're getting closer on each side to the asymptotes. They're going to fill out towards those asymptotes as you draw them. And once you draw a couple, you'll see more and more. Now, another thing too is get on something like Desmos or your TI and graph a bunch of them and see what they do, see how they move. That's the beauty of having those electronic resources, is you can easily graph, several in a really quick time and see how they move and change with them. You didn't expend a lot of effort, but you got to really see those changes and how things react. And obviously, the more you see, the more you'll be able to fill in as you get points, just like with all the other graphs you've memorized over time.